Okay, everybody, welcome back. Hopefully this video works out because this is the third time I'm trying to record this. So in this one, we're going to talk about surface area, volume, actually not volume in this one, just surface area. Volume will come in a later one. We'll talk about some prisms, cones, pyramids, and what else do we know? Spheres in this video and how to find their surface area. So, well, let's get to it. A couple terms we need to know first. The slant height versus the actual height. So slanted height of an object is literally the height of that slanted piece of it. There's a long worded definition there which you can take a look at. Lateral area is going to be that wraparound kind of area. So on a cylinder, it's easy to think about a soup can and its label. That label would be the lateral area. Lateral area for a pyramid, essentially all of the faces that encompass that object, right? So it's not the base. Essentially, they join it to that highest peak, that apex, vertex, if you want to call it that as well. You had a couple formulas when you talked about prisms, namely a rectangular prism and a cylindrical prism or a cylinder, right? You've got those underneath. So the combinations of the length, width, height basically to account for all of the sides on that rectangular prism. And for your cylinder, it's going to be the area of your base, since there's two of them and it's a circle, 2 pi r squared to account for both. The lateral area, 2 pi r h to account for that lateral piece. So if you think about unraveling that circle, its circumference would be 2 pi r. The height of that rectangle would also be like the width of that rectangle. So length times width would give you the area of it. So if we use that to help us out, we can then state out what the surface area of these objects is going to be. So 2 pi r squared plus 2 pi r h. If we fill in what we know, just remember that diameter is 15, so half of it is going to be that radius. So for us, that's going to be 7.5 squared plus 2 pi radius, again 7.5, height 24. So that surface area, if we plug all of it into our calculator, 1,484, doesn't specify where to round to, so let's leave it nearest whole number, make it easy, centimeters squared. Okay, so there's that area of that cylinder. Now, if we use that formula for the area of that rectangular prism, like we had up above, really it's just making sure we have all of the combinations of those numbers accounted for, the length, width, and the height. The order really doesn't make a big difference because multiplication and addition don't care about order. So we have 2 rectangles that are 5 by 2s. We have 2 rectangles that are 2 by 8 in size, and then the last 2 are going to be 5 by 8s. So our surface area is going to be 20 plus 32 plus 80. The surface area of that rectangular prism is 132 centimeters squared. So there we've got a little bit of review on how to use those formulas again. So we can focus this here. There we go. So if we take a look at pyramids then, you've got the base that's a polygon, so you've got your squares, your rectangles, whatever. Could be, yeah, you got your squares, rectangles, that's all there. We'll talk about tetrahedrons as well. A little bit different than a pyramid, just because the different numbering of faces kind of trips people up sometimes. So, in order to find the surface area of them, we'll find the area of the base, then the area of those lateral faces. The number of those lateral faces might change depending on the type of pyramid we're dealing with, but it works very much so the same. Okay, so you can give that a read as well. Height of that pyramid is the perpendicular distance from the apex to the center of that base. So that's helpful because sometimes we might actually have to find those slanted heights, which we'll talk about together underneath. So if we find the surface area of these regular tetrahedrons, 4 sides, right? Tetra meaning 4. All 4 of these faces are equilateral triangles, so there's not a set formula for this because we can build it. If the surface area it really is the area of the faces, if they're 4 identical triangles, just remember that it's base times height over 2, but since there's 4 of them, we'll multiply by 4. So if we fill in the information there, 9 is that base times by the height of that triangle, which is 7.8 over 2. So the area of one triangle is 9 times 7.8 over 2. Multiply by 4 to get all 4 of their areas combined, and we will find that the area of that works out to be 140 centimeters squared. So just to the nearest whole number, once again, nearest square unit, 140 centimeters squared. So if you like, you can try out that other one, and you can compare your result to the one in the SQ. If we talk about one of those rectangular pyramids underneath, This one's got a rectangular base, so we'll do B here together. You can talk about A as well if you would like to try it. That might be a square base pyramid because all of them are the same measurement. Okay, so 8 by 8 by 8 by 8. This one a little different because you've got 3 by 4 on the bottom. So I know it's rectangular, and the area of the triangles might be a bit different because of the dimensions. Right? One's got a base of 3, height of 5, the other base of 4, height of 6. So we need to account for all of the faces. So the surface area here, area of the base, plus the area of the faces, all those lateral faces, all those triangles. So the base is going to be length times width, plus 2 triangles, so base 1, height 1 over 2, plus 2, base 2, height 2 over 2, just to account for the differing dimensions. So if we plug in everything, we're going to have 3 times 4 for the base, plus 2, let's go 3 by 5 for this one, and then 2, 4 by 6 for the second one. And if you plug all of that in and get an actual number for it, we end up with 51 inches squared. Okay, so there's how that one would work out to find that surface area. Now, if we're given the actual dimensions but with no image, just be very careful that we're using the correct height. So for these two, C and D, they're very similar. E is kind of the challenging one of them because you have that rectangular base, so you have 2 differing slant heights. So people can attempt that one. So I'm going to do D here to give us a little bit of an idea of how this will work. So we've got a square pyramid, dimensions of 6 by 6 for the base, and the pyramid has a height of 8. It doesn't say slanted height anywhere, so I know it's not the height of the triangle. We're asked to find the surface area. So it helps to actually have a picture to go off of. So I'll try my best to get us a square here. So there's our square base. Go there. So we're trying as best I can to make a square pyramid. And that's the best I can do. So there we're going to have our 6 by 6. The height of this, straight from the apex to the center, that height is 8. And I know that drops right to the center of that base, so if the whole length is 6, partway through should be 3. Now I have enough information to find that slanted height. Let's call it x, just for ease, because sometimes my s's look like 5s. It's a little bit confusing. So and that is a right angle. So I know that x squared is going to be 8 squared plus 3 squared. So x squared is going to be 64 plus 9, so 73. So the actual value of x is square root 73. So I'm just going to leave it as that to use that, because if I use the decimal version and if I round it, it might not give me the exact answer. So we'll use square root 73. Now I can go find the area of this pyramid. So it's the area of the base again, plus the area of the faces, which is nice. If it's a square base, all 4 triangles on it are the same. So that surface area equals, the area of that base is its length times its width, so 6 by 6. 6 times 6 plus 4 times the area of those triangles. So 6 times root 73 over 2. If we plug all that in our calculator to get our actual number, we are going to have, where is this one here? 139. 139 meters squared. So you can try out C above it. You can try out E as well. Just remember that you need to find both slant heights to actually approach this one. You need both of those values from A to G and A to H to find the area of those respective triangles. Since the bases are different, the triangles are going to have different measurements for their areas as well. Just keep that in mind. So that takes care of essentially pyramids. Except for this part that I always forget. What happens if we're actually given the surface area and we work backwards to find out the measurements? So here again, we don't have a picture, which we don't really need one, because it says it's a square pyramid and the area is 6,500 inches squared. Side length of the base is 50. Determine the slant height to the nearest tenth. So our surface area, again, area of the base plus the area of the faces. So I know the surface area is equal to the base, which is length times width. Even if it's a square, the length and width just happen to be the same number. So I'm using this very generically because this could work for a rectangular base pyramid as well. Okay, so length times width plus, there's 4 triangular faces, so 4 base times heights over 2's. So if I plug in some numbers now based on what I know, actually, before I do that, the 4 and the 2 here actually can cancel part of them out. So instead of it being 4 over 2, let's use 2 over 1. And I'll rewrite that, just make it look a bit nicer. So the surface area equals length times width plus 2 base times heights. So there we go. Now I can plug some numbers in. So 6,500 is equal to 50 times 50 plus 2 times 50 times that height. So I know the length of the base was 50 because the question told me so. Length and width have to be the same if it's a square base. So if I subtract 2,500 from both sides of this, let's go up here. So 4,000 is equal to 100 times 8. So now that 100 just came from the 2 times 50. If I divide both sides by 100 now, 40.0 is actually the height of this. And with units, I believe that is inches. 40 inches equals that height. Okay, so that's slant height. Really, that's the height of the triangle. Okay, so the slant height is 40.0 inches. There we go. Okay, the one underneath, very similar, just in terms of a cube instead. So just remember that there are 6 sides on a cube, where its surface area is, if it's 1 square, side length squared, but there's 6 identical squares on a cube, so 6 s squared. So with the information given, plug in your surface area, work backwards, and you can find that side length as well. So you can attempt that one, and then compare it to that answer key. Okay, the next type of shapes we're going to talk about, cones and spheres. So for a cone, that formula really is 2 pieces. Pi r squared for the area of the circular base, pi r s for that lateral area. Okay, so when they give you the height, it really is from the vertex down to the center again, where you can see that right angle being formed. Now, in order to use this formula, I need the slanted height. So just be careful. We might have to use that Pythagorean theorem trick again to get the slant height to do this. So based on the information given, we've got a radius of 2, height of 7, we need the surface area. Now they just said height, so I know it's not slant height. So we'll break that triangle out again, pull it out of that cone. So let's say this is the slant height, this is the height, and this is the radius. Okay, so height is 7, slant height is unknown, let's call it x, radius 2. So we can use Pythagorean theorem one more time. So x squared equals 7 squared plus 2 squared. So x squared is 49 plus 4, x squared is 53. So x is equal to the square root of 53. Okay, we're going to use that measurement one more time, so let's just leave it as square root, and we don't have to round part way through. So our surface area is pi r squared plus pi r s. So our area is equal to pi times the radius of 2, which is squared, plus pi times that radius of 2 again, multiply by the square root 53. So if all of that stuff goes into the calculator and we multiply correctly, use the right values, 58. And I believe that is in feet squared. Okay, it does say nearest square foot, so we'll show you how to put that in there. Okay, so we're going to take all that stuff. So we can use our pi button. Let me get that out of the way. There we go. So pi times the radius squared plus pi again times 2, and then square root 53 is what we'll put in next. And there we go, 58.3086, but we said nearest whole number, so 58. Okay, you can try OB if you like. Again, you'll have the answer so you can compare and see how you did. We could also work backwards to figure this one out. So we're given the surface area this time is 220, diameter is 10, find the slanted height. Now if we know the diameter is 10, that means the radius is 5. Okay, so just be careful. So it's a cone again, pi r squared plus pi r s. So surface area is 220, pi times the radius of 5 squared plus pi times the radius of 5 multiplied with the slanted height once again. So what we can do here is look at that first term. It's really 25 pi. So we can subtract 25 pi on both sides. Okay, so that 220 minus 25 pi equals to 5 pi times s. It's the same term, just I switched around the 5 and the pi. If I divide by 5 pi on both sides, that will get us to our slant height, because those will cancel. So if we see how to put this one in the calculator, we can put it in all together. If you're uncomfortable, because that's a lot of buttons to press, just do it separately. So we'll do the numerator first, so in brackets 220 minus 25 pi, and then divide that by 5 times pi, again in brackets, just so our calculator does the right thing. 9.00, so to the nearest 10th, 9 centimeters. Because it does say nearest 10th right in that question, wherever my mouse is, right there. 9.0 centimeters is that slanted height. So just by working backwards a little bit, manipulating a little bit of that equation, we can find the missing measurement that we need. Now sphere is the last one that we will deal with. Now that surface area formula, 4 pi r squared, basically comes from doing a little bit of extra work just to derive it, but we'll just use the formula as is. We'll accept it for now. And the only thing we really need, that surface area is dependent only on radius. No other dimensions are important. So spheres are nice and easy to work with. So the diameter of that baseball, 3 inches. Again, that's a diameter. We need a radius, 1.5 inches. Find the surface area of said baseball to the nearest 10th. So that surface area is 4 pi r squared. So surface area is 4 times pi, radius 1.5. That is squared as well. So when you plug that into your calculators, we should get 28 inches squared. So let's just make sure 4 pi, radius of 1.5, that value squared, 28 to the nearest whole number. And that is inches squared. Okay, so there you go. Underneath, very, very similar type question. So we'll only do A here because there's B underneath, which is basically the same. So if you see how A works, you can try out B, and hopefully that one works out for you as well. So the surface area of this ball is 20 inches squared. So the diameter then is going to be, well, something to the nearest 10th, but just be careful that it's asking for diameter, not radius. So surface area, it is a ball, so it's a spherical object, 4 pi r squared. That surface area is 20, and there's your 4 pi r squared. We need to figure out a way to get r by itself. 4 is a number, pi is just a number, so we can divide by 4 pi. And that cancels out the 4 pi's from the right, so really it's r squared equal to 20 over 4 pi. Take the square root on both sides, and we are home free. You just got to figure out how to use the calculator. Usually it's the button pressing that'll mess people up, not usually solving the thing. So 20 over 4 pi. And I'm putting that 4 pi in brackets because what you're about to see is sometimes the calculator changes. So divide 4 pi. I don't get the same thing. If it's in brackets, my calculator is dividing by the product of 4 times pi, which is what we want. If I don't put it in brackets, 20 divides by 4, and that'll give you 5, and then it's doing 5 multiplied by pi. It's not giving you the thing you want. Just make sure you use brackets if you're going to do it together. So 20 divided by 4 pi. There's the answer I want. I need to square root that number. So take the square root of that answer. 1.26. 1.26. 16. Just a couple decimal places because I know I don't want radius. I want diameter. And again, diameter is equal to 2 times the radius. So 2 times that number we found should give me 2.5, I believe. So I rounded it 1.2616 times 2, 2.5 to the nearest 10th. And that is inches. There we go. So it does work out. Just make sure you're actually finding the correct thing that you need in the question. So that takes care of all the surface area stuff we're going to talk about Math 10. In the next video, we'll talk about all of the volume stuff that goes along with it. And then in the third one, I believe there'll be a third one for this, we'll talk about composite objects, basically just putting some stuff together. So what happens when you have like a half a sphere on top of a cylinder, or a pyramid on top of a rectangular prism, that sort of stuff. So hopefully this video works out this time, and then I don't have to record it again. So I hope everybody's taking care of themselves, staying well. I hope these are working out for you, and they do help. Let me know. It's always nice to hear from people. So until I hear from you, if I ever do. Have a great rest of your day, and stay safe.